From the moon to the sun, India is making history in space exploration. Just a week after landing on the lunar surface with Chandrayaan-3, India launched its first solar mission, Aditya L1, a spacecraft that will orbit around a special point in space where it will have a constant view of the sun and study its various aspects. The mission aims to solve some of the mysteries of our star, such as why its outer layer is much hotter than its surface and how it affects the Earth's environment. In this video, I will explain how Aditya L1 will observe the sun's outermost layers, how it will orbit around a special point in space, and how it will collaborate with other missions and observatories to advance our knowledge of solar physics and space weather. I will also discuss how this mission reflects India's achievements and ambitions in space exploration. Let's get started. Our sun is a huge ball of plasma, which is a state of matter that is like a gas, but with electrically charged particles. It has several layers, each with different properties and behaviors. The innermost layer is the core, where nuclear fusion occurs and produces energy. The energy then travels through the radiative zone and the convective zone, where it is transferred by radiation and convection respectively. The surface of the sun is called the photosphere, which is what we see when we look at the sun with our eyes or a telescope, and has an average temperature of about 6,000 degrees Celsius. But the sun does not end at the photosphere. Above it are two more layers that are much hotter and more dynamic than the surface. These are the chromosphere and the corona. The chromosphere is a thin layer of plasma that emits a reddish glow during a solar eclipse. It has a temperature of about 10,000 degrees Celsius. On the other hand, the corona is the outermost layer of the sun, which extends millions of kilometers into space. The corona has a temperature of more than 1 million degrees Celsius, which is much higher than the surface temperature. It is also where most of the solar wind originates, which is a stream of charged particles that flows from the sun to the rest of the solar system. The chromosphere and the corona are very important for understanding solar activity and space weather, but they are also very difficult to observe from Earth. This is because they are much fainter than the photosphere, and they are usually hidden by the brightness of the sun. To see them clearly, we need special instruments that can block out or filter out most of the visible light from the photosphere. We also need instruments that can detect other wavelengths of light that are emitted by these layers, such as ultraviolet or X-rays. This is where Aditya L1 comes in. Aditya is a spacecraft that carries 7 scientific instruments that will measure different aspects of the sun's activity in these outer layers. Some of these instruments are developed by India's space agency, while others are collaborations with other countries or institutions. By using these instruments, Aditya L1 will be able to observe the sun's outermost layers with unprecedented detail and accuracy. It will be able to answer some of the scientific questions that have puzzled researchers for decades, such as how the corona is heated to millions of degrees, how the solar wind is accelerated, or how the magnetic field changes over time. It will also be able to improve our ability to predict and mitigate the effects of space weather on Earth's satellites, power grids, and communication systems. To observe the sun's outermost layers, Aditya L1 needs to have a continuous view of the sun without any interference from Earth or the moon. This means that it cannot orbit around Earth or the moon, but it also cannot orbit around the sun directly, because that would require too much fuel and energy. So where can Aditya L1 go? The answer is a special point in space called Lagrange Point 1, or L1 for short. L1 is a point where the gravitational forces of Earth and the sun balance each other out, creating a stable orbit for the spacecraft. It is about 1.5 million kilometers from Earth, which is about 100 times farther than the moon. From this point, Aditya L1 can have an uninterrupted view of the sun at all times and also communicate with us easily. But how did Aditya reach L1, and how will it maintain its orbit there? Aditya L1 was launched by India's Polar Satellite Launch Vehicle, which is one of India's most reliable rockets. This vehicle has launched many satellites and missions for India and other countries, including Chandrayaan-3. It placed Aditya L1 into an elliptical orbit around Earth, with a perigee, which is the closest point, of about 250 kilometers, and an apogee, which is the farthest point, of about 18,000 kilometers. From this orbit, Aditya L1 will use its own propulsion system to gradually raise its apogee until it reaches L1. This process takes about 2 months. Once at L1, Aditya L1 will not stay exactly at that point, but will move around it in a halo-shaped orbit. This is because L1 is not perfectly stable, and there are other forces that can perturb Aditya L1's position and orientation, such as the pressure of the solar wind or the gravity of other planets. To avoid drifting away from L1, the spacecraft will use small thrusters to adjust its position and orientation periodically. These thrusters will use very little fuel, as they only need to make small corrections. So, what are the advantages and disadvantages of orbiting around L1? Well, one of the main advantages is that Aditya L1 can capture high-resolution images and data of the Sun at all times, without any interruption or distortion from Earth's atmosphere or Moon's shadow. This will allow the spacecraft to monitor the Sun's activity continuously and reliably. Another advantage is that Aditya L1 can communicate with Earth easily, as it always faces Earth from L1. This will enable Aditya L1 to transmit its data and findings to Earth quickly and efficiently. On the other hand, Aditya L1 will be exposed to higher levels of radiation and heat from the Sun than if it were orbiting around Earth or the Moon. This means that Aditya L1 needs to have a robust design and protection system to withstand these harsh conditions. For example, the spacecraft has a thermal shield that covers most of its body and reflects most of the sunlight away. It also has a radiator that dissipates the excess heat from the instruments and electronics. Another disadvantage is that Aditya L1 will be farther away from Earth than most other satellites or missions, which means that it will take longer to send commands or receive signals from Earth. This means that the spacecraft needs to have a high degree of autonomy and intelligence to perform its tasks and handle any contingencies. Solar physics and space weather are important fields of research that aim to understand how the Sun works and how it affects our planet and our technology. These fields have many applications and implications for science, society, and humanity, such as developing new sources of clean energy, enhancing our space exploration capabilities, or protecting our planet from solar threats. But studying the Sun is not an easy task. It requires a lot of data and observations from different perspectives and wavelengths. No single mission or observatory can provide a complete picture of the Sun and its effects. That's why Aditya L1 will collaborate with other missions and observatories to advance our knowledge of solar physics and space weather. It will complement or coordinate with some of the existing or planned missions and observatories that also study the Sun, such as NASA's Parker Solar Probe, which is the first mission to fly through the Sun's corona and touch the Sun. It will measure the properties and dynamics of the solar wind and the magnetic field near the Sun. European Space Agency's Solar Orbiter, which is a mission that will orbit the Sun at a close distance and a high inclination. It will take images and data of the Sun's poles and sides, which are hard to see from Earth. The International Space Station, which hosts several experiments and instruments that study the Sun and its effects on Earth's environment, such as the Alpha Magnetic Spectrometer, which detects cosmic rays from the Sun and beyond. Aditya L1 will share its data and findings with these missions and observatories, as well as with other international organizations or networks that are involved in solar physics and space weather research. By collaborating with these missions and observatories, Aditya L1 will contribute to our understanding of solar physics and space weather in many ways. It will provide new data and insights that will help us solve some of the mysteries of the Sun, such as why its outer layers are hotter than its surface, how its magnetic field changes over time, or what triggers its eruptions. It will also provide valuable information that will help us improve our prediction and mitigation of space weather events that can affect our satellites, power grids, communication systems, or even our health. It will also inspire new discoveries and innovations that could lead to new sources of clean energy, new ways of exploring space, or new ways of protecting our planet. Aditya L1 is a testament to India's achievements and ambitions in space exploration, and a contribution to global cooperation and understanding of our star and our home. I hope you enjoyed this video and learned something new about this mission and its objectives and instruments. If you have any thoughts or questions about Aditya L1, please leave them in the comments section below. I would love to hear from you. Thank you for watching, and don't forget to subscribe to my channel or watch my other videos.